Welcome everybody. Let's take a look at chapter 6.1 using the law of sines to find the area of an oblique triangle. And if you're sitting there going, I don't remember what an oblique triangle is, it's just a triangle without a right angle. So we have a triangle, no right angles to see. Triangle ABC, our sides are labeled little a, little b, little c. We're supposed to find the area. Well, what we could do is we could start at vertex C, drop a perpendicular straight down. That would create our right angle, and that would be the height of our triangle. And then we know the area of a triangle is just 1/2 times the base times the height. So how big is the base? Well, it's C. How big is the height? It's H. So the problem becomes, how do I find H? Because I'm most likely to be given the outside sides, I've got to be able to find H. And if you're sitting there going, well, we have a right triangle, in fact, you got a couple right triangles in there, you could come up with a couple different ways to find this. One way would be taking the sine of angle A. Okay, here's angle A. Sine of angle A would be opposite over hypotenuse, right? So opposite would be H, hypotenuse would be B. So looking at this little triangle on the left-hand side, opposite H, hypotenuse B. Now solving this for H, I'd multiply both sides by B. So H would equal B times the sine of A. Now what? Yeah, let's go ahead and plug in B sine of A for H. So we have 1/2 times C times B sine of A. This is basically, if I just do a little manipulation at this point, our formula for area of an oblique triangle. 1/2 BC, right? B times C, alphabetical order, sine of A. Jot that formula down in your notes if you don't have it already. I like to think of it more like this, though, because I'm probably not going to remember all that. I like to just think of it as 1/2, one of the sides, one of the other sides, and then the sine of what? Sine of the, let's see, if I have maybe B and C, I've got the included angle. So sine of included angle. When I say the included angle, I mean the angle between the two sides that you chose. So if you choose B and C, you want the angle in between A. If you were to pick two different sides, let's say you want A and C, well, then you need the sine of angle B. So it's just the angle that you didn't use the side of, right? I used B and C, I didn't use A, so I want sine of A. 1/2 times the side times the side times the included angle's sine. That's our formula for area of an oblique triangle. Find the area of triangle if D is equal to 29.7. I don't like how that looks. There we go. Find the area of triangle down. If D is equal to 29.7 meters, O is equal to 53.9 meters, and angle H is equal to 28 degrees 40 minutes. So what would you do? Well, the first thing you would do is you draw yourself a triangle, of course. So let's draw ourselves an oblique triangle. Go! Thank you, Homer. Labeling what we know. Side D, well, that's 29.7 meters. Side O, that's 53.9 meters. And angle H is 28 degrees 40 minutes. 28 degrees 40 minutes. So almost 29 degrees, not quite. You got to get to 60 minutes to make a full degree. If we're looking for the area of our triangle, our area would be 1/2 times a side. How about 29.7? Times another side. How about 53.9? Times the sine of the included angle. So 28 degrees, 40 minutes. Put this in our calculator, we'll have our answer. So, let me break out my calculator and switch over to that. One half times 29.7 times 53.9 times the sine of 28 degrees. Remember, your degree, minute, and second button is right here below delete. So I need to press the degree button, choose degrees. There's 28 degrees, 40, go back to your degree, minute, second button and choose minutes. So there's 28 degrees, 40 minutes. Tells me that my area is about 383.97 square meters. There we go. So, hopefully not too bad, right? 1/2 times the side, times the side, times the sine of the included angle. All right, give it your best shot. Find the area of triangle NHS if angle N is 24 degrees 40 minutes, side H is 27.3 centimeters, and angle S is equal to 52 degrees 40 minutes. Go ahead and hit pause, draw yourself a triangle, give it your best shot, and come back in a minute to check your work. All right, welcome back. Let's start by drawing ourselves an oblique triangle. No right angles here. N, H, S. Labeling what we know. Angle N, 24 degrees, 40 minutes. Angle S, 52 degrees, 40 minutes. And side H down here, 27.3 centimeters. And if you're sitting there thinking, well, area, I need two sides and the angle between them, you're right, you do. So how can we find our missing side, right? We need two sides. We have one. Well, law of sines. A over sine of A equals B over sine of B equals C over sine of C. So I need to figure out my missing side, whichever one I want to use. How about I start by finding angle H. So angle H, 180 degrees minus 24 degrees, 40 minutes, minus 52 degrees, 40 minutes. Put that in your calculator. Use your degrees and minutes button to find what you have. All right, I've got 102.6 repeating. And yes, you could use that. Now you might be thinking, well, how do I change that into something like minutes, right? Well, if I take out the 102, that leaves me 0.6 repeating, and there are 60 minutes in a degree, just like there's 60 seconds in a minute. So if I just take 0.6 repeating times 60, I will get 102 degrees and 40 minutes. You could do some borrowing over here. You could make this 179 degrees and 60 minutes. Take off your 2440. See what's left? And then you'll probably have to borrow again, but you could end up by using 179 degrees, 60 minutes to start with as you subtract off your first one. So it's just borrowing from your degrees. Every 1 degree makes 60 minutes. So here's angle H. 102 degrees, 40 minutes. All right, so I've got my 3 angles, but I still don't have a side. We need law of sines. I can do the sine of this angle with this side. I can do the sine of this angle with this side, and then I'll have 2 sides. I can use my formula, area is 1/2 side, sine of included angle. So let's try that. 27.3 over sine of 102 and 40 minutes equals, I don't know, little n over sine of 24 degrees, 40 minutes. Cross multiply and see if you can come up with your side for n. So 27.3 times sine of 24 degrees, 40 minutes, divided by sine of 102 degrees, 40 minutes. I got about 11.68. So knowing that this side is 11.68, I can now turn to my formula to find the area. 1/2 times a side, how about 11.68? Times another side, like 27.3, times the sine of the included angle, which was 52 degrees, 40 minutes. Put this in our calculator, and we should be able to come up with our answer. about 126.7 square centimeters. All right, at this point, you and your group should probably spend about 15 minutes working on chapter 6.1, area of oblique triangles. Hit pause in your notes, work on this with some partners, one paper per group. If somebody doesn't do anything, cross off their name or help them. That would be a novel idea. I like that idea. When you're done with that, come on back, we'll finish our notes. Welcome back. How about a little brain break? What is the dotted line called? This was the Hogwarts math test for you Harry Potter fans. It's not as easy as it seems. It's the Elder Wand, right? Doesn't it look like it? Yeah, I got marked wrong anyway. Somebody was not a Harry Potter fan, I guess. Question for you. Why do we put round pizzas in a square box and eat it in triangles? I think it's a conspiracy. There must be some math involved somewhere. Why do they call it a pizza pie, right? Ooh, yeah. All right, so the last thing we're going to look at today is a little bit of the ambiguous, meaning unclear, the ambiguous case of the law of sines. Specifically, we're looking at SSA. Try not to read it backwards. Where we are given two sides and one opposite angle. What can happen is we can end up with no triangle at all because the sides just don't reach. There might be no solution. We have a side, we have another side, and depending on the opposite angle, we may or may not be able to form a triangle. In this case, this side is less than the height. It's just not gonna reach. Maybe we end up with one triangle. Well, there's one solution then we can find. We have a side, we have another side, and we have our angle. Well, it just happens to make it work, where the height is the same as the length of this side. So A is equal to H. And then our next possibility, we might have two solutions. There might be two triangles that we can form based on the data that we're given. We're given a side, and then we're given another value for A. Well, maybe A goes this way, and there's our angle. We form a triangle. A is somewhere between H and B. Maybe the triangle comes this way, though. So maybe we get an acute triangle, maybe we get an obtuse triangle, but we get more than one possible answer. And because we get all these different possibilities, that's why this is called the ambiguous case. When you're given two sides and an opposite angle, we got a lot of different things that could happen. And instead of sitting there trying to memorize all these, because nobody's going to do it, nobody really, nobody's going to do that, it's probably easiest just to plug through and try it out and see. Do I get a solution? Do I get no solution? Do I get two solutions? And if I do, find them. So the trouble comes from the fact that sine is positive in two quadrants. Quadrant 1 and quadrant 2. So maybe my angle here is an acute angle. But maybe my angle is an obtuse angle and my angle is all the way into quadrant 2. We have the same reference angle here or here, so it's the same sine values. The only difference is one's going to be a positive, one's going to be a negative. And that's why we're getting this ambiguity here. So we get two possible triangles in the ambiguous case if there are two solutions to be had. Let's take a look at what's going on. We've got a big triangle. This is 10, this is 7, this is 30, this is 40. Well, this 7 could go this way instead. So we could end up with this big triangle over here, 10, 7, 30, 40, right? Which makes this angle how big? Yeah, 110. Or we could end up with this little triangle here. Oh, this one's so cute. Look at that little triangle. Well, this is still our 10. This is our 7. This is our 30. All right? This is definitely acute. This is definitely obtuse. So we've got all these different possibilities here. And that's why we have the ambiguous case of the law of sines. So let's see if we can make a little sense out of this. Solve triangle ABC. Given angle A is 55 degrees. Side B is 25, side A is 9. Well, the first thing I do is I draw myself a triangle. And it's probably not going to be totally accurate, and that's okay. That's not the point. Can you draw an accurate triangle? The point is, can we just figure this thing out? So, A, B, C. A is 55 degrees. B is 25, A is 9. What you have side, side, and an angle. That's SSA. That's ambiguous. Yeah, I can't say it. Ambiguous. It has some ambiguity to it. That's what I was trying to say when I said ambiguous. Next to two words up. Oh my goodness, I said something wrong. I'm gonna go cry. I'll live. It'll be okay. So let's use the law of sines and see, do we actually get an answer? Okay. So 9 over sine of 55 degrees equals 25 over sine of B, right? This side, this angle. This side, this angle. We'll go ahead and cross multiply and see what we get. So 9 times sine of B is 25 times sine of 55 degrees. I got 20.48. Divide by 9. Sine of B is about 2.28. Well, at this point, what you should be saying is, hey, wait a minute. Sine has to be between 0 and 1 or 0 and negative 1. I can't have a sine equal to 2.28. And even if I tried to do an inverse sine of 2.28, it would tell me there's a domain error because I can't take a sine value bigger than 1 or smaller than negative 1. Therefore, there is no triangle possible with these measurements. What we end up with is this case right here. We try to make a triangle, it just doesn't happen. Hey, let's try to solve triangle. Hey! Given H is 32 degrees, side H is 100 inches, and side E is 150 inches. What's the first thing you do? That's right, you draw yourself a triangle. Doesn't have to be perfect, doesn't matter. But hey, let's just give it a shot. H, E, Y. Not to be confused with hey hey. Hey hey is great, right? We love hey hey. All right, h is 32 degrees. Little h, 100 inches. Little e, 150 inches. Guess what we have? We have side, side, and an angle, SSA. And again, remember, not to read them backwards. Don't go A, S. Yeah, we are not going to do that. Well, maybe we will. No, we won't. Okay. So, let's consider what's going on. If we set up 100 over sine of 32 degrees and set that equal to 150 over sine of E, right? This side, this angle. This side, this angle. We can cross multiply. Why don't you pause for a minute? Go ahead, you try to find how big angle E is. Go ahead, I'll wait for you. All right, so cross multiplying, 100 sine of E is about, I don't know, 150 times sine of 32 degrees, 79.49. Divide by 100. So sine of E is about 0.7949. When you're doing these, you really want to take it out about 4 decimal places to get the best angle possible. Inverse sine of 0.7949 tells me that angle E is about 52.6 degrees. Well, guess what? That gives me this angle here, 52.6. I can now find angle Y. It would be 180 minus 52.6 minus 32, and we'll have our answer. About 95.4 degrees. Well, that's great. Let's go ahead and find how big Y is. We're supposed to solve the triangle. That means we find all the different measurements, all the different sides. So now we have this angle is 95.4. We have this angle is 52.6. The only thing we need is side Y, and it will be solved. So I'm gonna go 100 over sine of 32. Right? This side, this angle. This side, this angle. Little y over sine of 95.4 degrees. Cross multiply, and let's see what we come up with. So I get y is about 100 times that divided by that. 100 times sine of 95.4 divided by sine of 32. Well, that's your first possibility. This is case 1. We have another possibility here. Because our angle that we found originally, our theta, was only 52.6 degrees, we could also have quadrant 2. we have quadrant 1 where our angle, 52 degrees, is sitting in quadrant 1. Now, if we want the reference angle in quadrant 2, we would go 180 degrees minus my original answer for E. So let's take a look at case 2. This is case 1. So my angle E, I already have an E. I will call this new one E prime. And it's going to be 180 degrees minus 52.6 degrees. Because again, you're thinking of your quadrants, right? If 52 degrees is here, you could also have a possibility of here. So 180 minus whatever that is would give you your big obtuse angle. And that's what we're finding here. So 180 minus 52.6. Got 127.4 degrees for E prime. So if we have a new angle E, we also have a new angle Y. So Y prime would be 180 degrees minus my 127.4 minus my 32 degrees that we started with. Break out your calculators. So my new possibility, Y prime, would be about 20.6 degrees. What we have is that triangle where maybe it goes this way, maybe it goes this way, and it gives us two possibilities. It gives us an obtuse triangle, and it gives us an acute triangle. All right, so we've got our new E prime. We just need to figure out our new little e, not little e, little y side. So here's what we have. Still 32, 20.6, 127.4. This is still, E and Y is still 100. H and Y is still 150. We've got to find little baby Y prime. And if you're thinking, well, law of sines, yes, indeed. So this side, this angle, 100 over sine of 32. We need this side, so we need this angle for y. So little baby y over sine of 20.6 degrees. We'll cross multiply. I'll make this my little baby y prime. So 100 times sine of 20.6 divided by sine of 32. 100 times sine of 20.6 divided by sine of 32. Little baby y prime, 66.4 inches. Two possible cases. Whew, that was rough. Wasn't that great? How about a brain break? Buying books, he says, I'll take 2 Math for Dummies. They actually have those kind of books. Math for Dummies at $16.99 each. And she says that'll be $50. Aren't you glad you can do math? Triangle says, feels like 90 degrees out here. Right triangle. Circle says, it feels like 360 degrees to me. Haha, good one. All right, give it your best shot. Solve triangle CAT given. Angle C is 112 degrees. Side C is 4 feet. Side A is 3 feet. Pause, come back, check your work, and then you guys are going to finish up with a Desmos activity before you roll out. And of course you'll have homework. What were you thinking? All right, let's see how we did. So, well, I notice I have a 112 degree angle there, so I guess I got to draw something with a 112 degree angle. So far, so good? Yeah. How you label it really isn't all that important. If you labeled it a little differently, that will still work out okay. The important thing is you start putting the numbers in the right spots. So here's 112 degrees. C is 4 feet. A is 3 feet. If we're solving, that means we're going to need our other angles and our other sides. So we have side, side, angle. Ambiguous. Alrighty, I love it. I don't know if I'm going to have no answers, one answer, or two answers, but we'll figure it out as we go. This side, this angle. This side, this angle. Alright, so 4 over sine of 112 degrees equals 3 over sine of A. Do a little cross multiplying. 4 sine A equals 3 sine of 112 degrees. Calculator time. 3 sine of 112 is about 2.7816. Divide by 4. Sine of A is about 0.6954. Inverse sine, so second sine of 0.6954 tells me that angle A is about 44.1 degrees. Well, how big is angle T? Minus 44.1 minus 112. T is 23.9 degrees. All right, so we've got angle A and T that we found. If we're solving, we need all three angles and all three sides. We have 3 angles and 2 sides. So we need to do law of sines once more using this side and this angle. And then we could pick either of the 3 and the 44.1 or the 4 and the 112 to do the other side. But I have to have this missing side, little baby t, over angle t equal to one of the other sides with its respective angle. Doesn't matter which one. I'll just start with the one I was given, because maybe, just maybe, I goofed up and, you know, it's gonna just get even worse. I'm gonna be even further off. So 4 over sine of 112 degrees. Yeah, I could make a mistake. It could happen. I could have goofed up. That's right. Anything's possible. I mean, with my age, woo-hoo. All right, cross multiplying. 4 times 23.9 divided by sine of 112. 4 times sine of 23.9 divided by sine of 112. So little baby t is about 1.75 feet. So, is there a second possible case, right? The last problem, we had 2 possible cases. Let's try it. If we're going back to A, and we'll find an A prime and a T prime, let's see what happens. Okay, so A prime. Well, I would take, because this is in quadrant 1, I would take 180 minus 44. 0.1, and my A prime would then be how big? 180 minus 44.1, okay, 135.9 degrees. So that means I would have a triangle that has an angle of 112, 135.9, and don't forget there's a T prime. Is there a problem with that? 112 plus 135.9 plus something else has to equal 180. Didn't we already go over 180? So that tells you there is no second possibility. You can't go past 180 degrees. So that's how you know if you have one possible case, 2 possible cases, or no possible cases. Give the ambiguous case your best shot in Desmos. Good luck, and don't forget to do your homework, of course. It will be on paper. Bye, guys.